Welcome to iLecture Online, and here we're going to continue talking about thermodynamics, but we're moving on to the next topic. This has to do with the second law of thermodynamics, and I'll give you some details about that in the next several videos. But the first thing we're going to look at is the efficiency of a heat engine. Now it turns out that in the applications around the world, we use heat engines all the time. It started out with the steam engine, and now of course internal combustion engines and so forth. So a lot of applications in the world today, and the basic principle of a heat engine is that it takes advantage of the heat flow from a hot reservoir to a cold reservoir. In nature, heat typically flows from hot to cold on its own. Nobody has to push it to do that. And a heat engine takes advantage of that heat flow. Somehow it diverts part of that heat flow and does work with it. So that's what the W represents. Q means heat, so this is the heat from the hot reservoir, Q sub H, and the heat being expelled to the cold reservoir, Q sub C. And the efficiency of an engine can be defined as the ratio of how much work can be done by the amount of heat that comes out of the hot reservoir. Now remember, this is simply just a graphical representation of a heat engine. Here's the engine, there's a supply of heat, and there's the exhaust location, the place where we would dump the heat that is not being utilized to do work. And so by definition, the efficiency is how much work we can do divided by the amount of heat that we used on that heat transfer. And of course, the more you can divert to work, the more efficient your engine becomes. Now also you can realize here that the amount of work that you do is simply the difference between how much heat you get from the hot reservoir and how much heat is expelled and not used to do work. So if we then use the equation that the work done is equal to Q hot minus Q cold, simply the difference, and we replace that in here, we can also write the efficiency of an engine equal to the difference between Q hot and Q cold. Let me write it like that, divided by the original Q hot. And of course, again, if you look at it, there's two ways actually to look at it. Either you want your work to be as much as possible as a ratio of how much heat you had available, or simply the difference. You want to expel as little of heat to the cold reservoir as possible to make this quantity as big as possible. And of course, you can realize that efficiency can never be greater than 1. And as we will learn later in thermodynamics, with the second law of thermodynamics, that the efficiency can actually never be equal to 100%. It always has to be less than 1. In other words, Q cold is never 0, so this quantity right here will always be less than Q hot. And so that's the basics of the heat engine and the efficiency of a heat engine. In the next videos, we'll talk about the second law of thermodynamics, different ways of looking at it, and then we'll look at some applications of how to use this.